Today we are going to learn how to determine whether a number is considered rational or irrational. You should be on page 6 in your yellow notes packet. A rational number is a number that can be expressed as a fraction and also a terminating and repeating decimal. Remember that anything that is a whole number, so for example, the number 5, the number 5 can be written as 5 over 1. Because it can be written as a fraction, it is considered a rational number. Terminating decimals, so for example 0.27, can be written as fractions because this really says 27 hundredths. Well, I can write that as a fraction as 27 over 100. Because of that, terminating decimals, which are decimals that end, are considered rational numbers. Repeating decimals are also considered rational numbers because just like we did yesterday, we saw that when a number repeats, for example, 0.2 repeating, it can actually be written as a fraction. So 0.2 repeating is the same as 2/9. So even though this decimal does not terminate, it does have a fractional equivalent, so it would be considered a rational number. Irrational numbers, however, are those numbers that cannot be expressed as fractions. One of the most famous irrational numbers is pi. We know that pi is a number that goes on forever. It has no pattern. It does not terminate. It is considered irrational. Another type of irrational number are non-terminating and non-repeating decimals and those squares of square roots of non-perfect squares. For example, when we say square root, if I ask for the square root of a number like 25, what I'm asking for is what number can be multiplied by itself to get 25? Well, that answer would be 5 because 5 times 5 gives us 25. If I asked for the square root of 64, I would know that the square root of 64 is 8 because 8 times 8 gives us 64. However, if you have a non-perfect square, so for example, if I say the square root of 20, if I looked at the square root of 20, there is not a perfect whole number that can be multiplied by itself to get 20. Remember, this is not the same as saying what number times 2. It's what number times itself. So, since no number that is a whole number can be multiplied by itself to give us 20, this is going to give us an imperfect square. This would be considered an irrational number. Look at the table and I want you to see if you can tell whether these are rational or irrational and explain why or why not. Let's check your answers. -8 is a rational number. Remember that -8 can be written as -8 over 1. So any whole number or integer would be considered a rational number. 0.7 is also a rational number. This is a terminating decimal. And remember, terminating decimals can always be written as fractions because technically this says 7/10, which I could write as 7 over 10. 0.123456 with dots behind it, those dots represent that this pattern continues. However, it does not in this case show that anything is repeating. Because it doesn't show that any of these numbers repeat and those dots indicate that it goes on forever, this would be considered an irrational number. So it does not repeat, it does not terminate, which means it actually cannot be written as a fraction. So it is irrational. 0.3 repeating is considered a rational number. This is a repeating decimal. All repeating decimals can be written as fractions. Remember that 0.3 repeating is actually 3/9, which would simplify to 1/3. So because that can be written as a fraction, that is considered a rational number. 5/8 is also a rational number because it is already written as a fraction. Anything that can be written as a fraction is rational. The square root of 20 is considered an irrational number because it is not a perfect square. There is no number that can multiply by itself to give us 20, so this is an irrational number. The square root of 144 is rational, and this is because I know that the square root of 144 is 12, because 12 times 12 gives us 144. So because this answer is a whole number and any whole number can be written as a fraction, so 12 over 1, this would be considered a rational number. Now I want you to answer questions 1 through 8 on page 7. Let's check your answers. Number 1 says Carlos wants to find the side lengths of a square that has an area of 150 feet. Will the side length be rational or irrational, and why? Well, if we have a square and we know that the square has an area of 150 feet, we know that to find the area, we would do length times width. But with a square, those numbers are the same. So you're really doing whatever the length is times whatever the length is again, because the length and the width are the same, and you're getting 150. Well, 150 is not a perfect square. We don't know a whole number that can multiply by itself to give us 150. So because of that, this number is going to be irrational. Number 2 says which value or values from the list are not a rational number. Well, 8.34 is rational because this is a terminating decimal. 5/9 is also rational because it's already written as a fraction. The square root of 25 is rational because 5 times 5 gives us 25. 0.348 with a bar over it is rational because that is a repeating decimal. However, the square root of 75 is irrational. This is because there is no number that can multiply by itself to give us 75. So it is considered a non-perfect square, which means that it is irrational. But every other number in that list is considered rational. Number 3 says which value or values from the list are not rational. Well, 8.3 repeating, that is a repeating decimal, and we know that all repeating decimals are rational numbers. 4/7 is written as a fraction, so we know that it is a rational number. The square root of 221. This is irrational. We know that there is not a whole number that can multiply by itself to give us 221. So since this is a non-perfect square, this is irrational. 4.67 is a terminating decimal, so it is considered a rational number. However, 3.14 with 3 dots after it indicates that this number continues on forever, but because there's no bar, it does not show us that this is repeating. So because we don't know if this is repeating and we know that it goes on forever, we would consider it irrational. Number 4 says Cassandra converted 5/11 to a decimal, and her result was a repeating decimal. Does this mean that the value is rational or irrational, and explain? Well, first off, we know that 5/11 is a fraction. So since 5/11 is a fraction, it is automatically a rational number. But also, since we got a repeating decimal, and we know that repeating and terminating decimals are rational numbers, we know that this number is rational. Number 5 was to tell whether the given values were rational or irrational. Well, 1.2345 is rational because this terminates. Any number that terminates is going to be a rational number. 1.2345 with 3 dots after it is irrational. We know that this number goes on forever because that's what the 3 dots indicate, but there is no bar to tell us that anything repeats. Because we know this goes on forever, but we don't know the pattern, we would call this an irrational number. C says 1.2345 with the bar over the 5. Well, because we know that the 5 repeats, we know that we can write this number as a fraction, so this would be a rational number, and any decimal that repeats is going to be rational. For number 6, we are also figuring out whether these are rational or irrational. A is the square root of 22. Well, there is no number that can multiply by itself to give us 22. So because of that, this is a non-perfect square, and non-perfect square roots are always considered irrational numbers. B says 1/2. Well, remember, any number that can be written as a fraction is a rational number, so this is rational. C is the same thing. It is 1 over 22, which is a fraction. If a number can be written as a fraction, it is automatically considered a rational number. Number 5 says state whether the given values are rational or irrational. Well, A says 5 plus the square root of 20. Well, you would have to sort of think about what this means. This means we would have to add 5 to whatever the square root of 20 is, but we don't know the square root of 20. The problem with the square root of 20 is that this is a non-perfect square. Because we don't know what number would multiply by itself to give us 20, we don't know what that number will be, but we know that this will be irrational. And if we take an irrational number and add it to 5, which is rational, it's still going to be an irrational number. And this is because 20 is a non-perfect square. Now, B says the square root of 5 plus 20. Well, in this case, because 5 plus 20 is underneath one radical symbol together, we would be adding the 5 and the 20. So this really says the square root of 5 plus 20, which is 25. Well, if we found the square root of 25, we know that that is equal to 5 because 5 times 5 gives us 25. Well, since 5 is a whole number, we know that this is rational, and that's because 25 is a perfect square, which gives us a whole number answer. C says the square root of 5 plus the square root of 20. Well, this is considered irrational. The reason is that both 5 and 20 are non-perfect squares. There is no number that can multiply by itself to give us 5, or no whole number, and there is also no whole number that can multiply by itself to give us 20. Because they're in separate square root symbols, this really tells us that we would have to find the square root of 5 first, then find the square root of 20 and add them together. Since we cannot find both of those without getting an irrational number, when we add them together, that number will continue to be irrational. Number 8 says give an example of an irrational number that is greater than 12. Well, you could have any answer here that would be greater than 12. An example that I have is the square root of 160. Remember, we know that the square root of 144 is 12 because 12 times 12 is 144. So we could put any number inside of a square root that would be greater than 144. We could even put 145. That number would be irrational, and it would be greater than 12.